Another new shape. This is 9-5. We're learning about hyperbolas, which are a lot like parabolas, but then there's like two of them and they're mirrored. Anyway, let's do a quick review of an ellipse. So suppose we have x squared over 36 plus y squared over 25 equals 1. So we know that this ellipse is going to be a center of 0, 0. We also know that I'm going to go out by the square root of 36, which is 6 out from the center, and then 6 out from the center in the other direction, in the x direction, and then of course 5 up and 5 down in the y direction. And then I would connect that with an oval shape, which would, in theory, be much nicer looking than the one I've drawn. And we also know that we find the foci by doing c squared is equal to a squared minus b squared, which would be 36 minus 25. So therefore, c is equal to plus or minus the square root of 11. And so I'm always going to go along the longer axes. In this case, it's going to be the x-axis that's longer, and our two focal points are going to be the square root of 11, 0, and negative square root 11, 0. So what we're going to learn is that a hyperbola looks almost the same as an ellipse, except that a hyperbola has a minus sign right where that plus sign is. But otherwise, their standard equations are exactly the same. So let's go ahead and figure out how we actually draw a hyperbola. So if we wanted to draw the set of all points, let's say we have these two focuses, right? Let's draw the set of all points where PF1 minus PF2 is a constant. Okay, so notice this is very similar to the way that we defined ellipses, except that ellipses were the sum of PF1 and PF2 is a constant. In this case, it's going to be their difference is a constant. We get this shape that looks like a double parabola going in both directions. So let's go ahead and look at a specific example where we have x squared over 9 minus y squared over 16 is equal to 1. Okay, the very first step is we're going to make a box the exact same way that we made ellipses. I'm going to draw a box on this one just so you can recall how we had that box as a guide. So what I'm going to do is I'm going to look at the number underneath my x squared, which is 9, and I'm going to take the square root of that, which is 3. I'm going to go out 3 from the center in the x direction, out 3 from the center in the x direction the other way, and then I'm going to go up by 4 and down by 4 away from the center, which would be 0, 0. And then I'm going to draw my box with a dotted line. My second step in drawing a hyperbola is I'm going to draw dotted lines through this box. Okay, so through the corners of the boxes. So I kind of make this giant X, which is going to be, these are going to be called asymptotes. Asymptotes is like a guide that kind of helps you graph, right? Where your graph will never really touch that, but it will only approach it. Now, the equations for these lines, I notice that I'm going, down 4 and over 3, so my slope is negative 4/3, and it's just going through 0, 0, so the equation for the line is negative 4/3 x, the other one is positive 4/3 x. So then I need to ask myself, is x or y first? In this case, x is first. Therefore, it is going to be a sideways hyperbola, so it's going to look like this here. And I'm going to use the asymptotes as a guide. So I kind of draw my hyperbola really close to the asymptotes. I don't actually need to plot any points. I'm just going to draw it approaching those dotted lines to the sides, those asymptotes. The fourth step in graphing a hyperbola is to find the foci. So in this case, c squared is going to be equal to a squared plus b squared, whereas those a squared and b squared are just the numbers underneath the x squared and the y squared. So I'm going to do 9 plus 16, which is 25. Therefore, c is plus or minus 5. And since this hyperbola is opening up in the x direction, the hyperbola has to scoop up both of the foci, so I put them along the x direction. So it's the point 50 and the point negative 50. That is how we graph a hyperbola. Let's take a look at another example of graphing hyperbola. This time we notice that we're going to have a y squared first. So very first thing that I need to do is I need to divide both sides by 25 so that I can get this in the form of y squared over 25 minus x squared over 5 is equal to 1. Okay, I want the other side equal to 1 so I can graph this easily. Okay, again, the first step in drawing this is to first draw the box the exact same way that we drew the box with the ellipses. So I'm looking at the base underneath my y squared and looking at the base underneath my x squared. and drawing my box based on those numbers. So underneath my y squared, I have 25, so I'm going to go up 5 and down 5 from the center. And then underneath my x is 5, so I'm going to go square root 5 over to the left and square root 5 over to the right from the center, which is 0, 0 in this case. And then I'm going to take dotted lines through the corners of the boxes. And this dotted line is going to have an equation of 5, because it's going up by 5 and then over by root 5. So it's going to be 5 over root 5x and then negative 5 over root 5x. Those are my two asymptote equations. Now I see, is x or y first? Well, in this case, y is first. So I'm going to draw the hyperbola going up and down like so, using the asymptotes as a guide so I can draw that hyperbola correctly. And lastly, I would find the foci by doing c squared is equal to a squared plus b squared, 25 plus 5, which is equal to 30. So c is equal to plus or minus rad 30. And of course, we draw them in the y direction because y was first and because our hyperbola has to scoop up those foci on either side. So we see them just above at 0, root 30 and 0, negative root 30. Let's do an example where we need to find the equation. Actually, first, let's go ahead and look at the standard form for a hyperbola. The standard form for a hyperbola is x squared over a squared minus y squared over b squared equals 1. That's a hyperbola that goes sideways. And then we have y squared over a squared minus x squared over b squared is equal to 1. That's a up and down hyperbola. But I always know that c squared is always equal to a squared plus b squared. So I just add those two bases underneath the x squared and the y squared. The last thing we'll talk about is the difference in focal radii, which is going to be equal to 2a, similar to the sum of focal radii with ellipses, but hyperbolas are described by doing the difference in the two focal radii, and that's how we draw them. Notice that a squared is just going to always be underneath whichever one is first, whether it's y squared or x squared that's first. So we're given two foci, negative 4, 0, 4, 0. The difference in focal radii is 4. So therefore 2a is equal to 4, and a is equal to 2, and a squared is equal to 4. I also know that c is equal to 4 because that's the difference, the distance between 0, 0, which is probably my center, and the focus, which is, at 4, 0. So c is equal to 4, c squared is equal to 16. And then I would set c squared equal to 16, a is 4, and I solve b squared is equal to 12. So I know that the foci are in the x direction, right, in relation to each other. So therefore, my x squared term should be first, right? This is a sideways parabola. So I'm just going to do x squared over a squared minus y squared over b squared is equal to 1. Remember that you always do a squared underneath whichever one is first for hyperbolas. It was different for ellipses, but for hyperbolas, we just put a squared underneath the one that was first. A is no longer the bigger number like with ellipses. So let's suppose that we have another example. Let's suppose we have two asymptotes that they give us. The first asymptote is root 2 over 2x. The second one is negative root 2 over 2x. The center, again, is going to be 0, 0 because our foci are sort of centered about 0, 0. We have 0, negative root 6 and 0, root 6. So I'm going to start to graph this so that we can kind of see what's going on here. So our asymptotes have an equation of root 2, so up by root 2 and then over by root 2. So I'm going to draw my boxes kind of based on that, going, up by root 2 from the center and then over by 2 from the center. And once I draw that box, I can kind of see that I have an a and b value. So first I need to figure out whether y is first or x is first. Well, I look at my foci and I see that they're, in the y direction in relation to each other, right? There would be one there, and then there would be the other one there. And because they're in a vertical relation with each other, then I know that y squared is going to be first. So I do y squared over whatever a squared is. In this case, it would be 2. And then minus x squared over 4. I'm actually looking at the rise and the run of my box, right? So the one underneath the y should be root 2, because that's how much I rose by. So y squared over 2, root 2 squared, which is y squared over 2. I take another example where I have two asymptotes again. One is y equals x. The other one is y equals negative x. Okay, so these are just 45-degree lines. Okay, but I don't actually know whether these were made by having a slope of 1 over 1 or 2 over 2 or 3 over 3 or 4 over 4, etc. You get the idea. I don't know what the actual slope. I just know that the A and B values, right, how much I go up by, how much I'm going over by, are the same. So they give me one other piece of information. I know that the foci are -4, 0 and 4, 0. So what I'm going to do is I'm going to figure out how to, first of all, where my foci are. I graph those. I get 4, 0 and -4, 0. So then I know that my hyperbolas are scooping up those foci, so I draw those hyperbolas. I realize that x needs to be first because this is a sideways hyperbola. So I write x squared over something minus y squared over something is equal to 1. And now I'm going to take a look at my c squared equals a squared plus b squared equation. Since a and b are the same, then I'm just going to replace that with 2a squared. Therefore, 4 squared is equal to 2a squared, and a squared is equal to 8. So I would actually put an 8 underneath both my x squared and my y squared. They both have the same number, and I determined that from knowing what my foci were. Okay, let's suppose that I have an inequality with a less than or equal to sign. And let's suppose I rearrange this so that I get 4 is less than or equal to x squared minus y squared, and then x squared minus y squared is greater than or equal to 4. I'm going to divide both sides by 4, and I get x squared over 4 minus y squared over 4 is greater than or equal to 1. So I'm going to start by drawing this hyperbola. I know that it has a box that's, 2 in both directions, right? Because the number underneath my x squared is 4. The number underneath my y squared is also 4. So I just go 2 up from the center, 2 down from the center, 2 left from the center, 2 right from the center. And I also know that my x is first, so this hyperbola is going to be in the x direction. And lastly, what I'm going to do is I'm going to figure out what my foci are. C squared is equal to a squared plus b squared, which is 4 plus 4, which is 8. And therefore c is equal to 2 root 2, and I would graph that. That's the point 2 root 2 or root 8, 0, and then 2 root 2 or negative root 8, 0. So then I'm going to take a look at that inequality sign, right? It's greater than or equal to. So it's good that I drew solid lines for my hyperbola graph. If it was just greater, then I would just draw dotted lines. And then I'm going to shade kind of on the outer region of my hyperbola. If I had a less than or equal to sign, I would shade in between the two shapes. Thank you, and have a great day.